So let's jump into the deepish end of the exercise. No. We'll do a simple one first. Exercise 3.7, and we'll do question 1. It's probably not going to get any more simple than that. So we're given the curve x equals y squared, and we have the lines y equals 0 and also y equals 4. So it looks very similar to what we've had before. It's just now it's to do with the y-axis rather than the x-axis. So a little sketch is still called for. All right, and y equals x squared is a parabola that goes like that. So x equals y squared is a parabola that goes like this. All right, looks like that. It says find the area bounded by the y-axis. The curve x equals y squared, and lines from y equals 0 to 4, so we're going to have, well, the line y equals 0 is actually aka the x-axis. So it's from here and up to there, so there's where y equals 4, and we're looking for this area in here. Alright, and the area is going to be given by the integral from 0 to 4, of this function, y squared, with respect to y. And the rest of this is, we're using y's instead of x's, but it's exactly the same process. So we'll have y cubed on 3 from 0 to 4, which will give us 4 cubed on 3 minus 0 cubed on 3, and 4 cubed is 64 on 3, which is probably going to come out as 21 2/3 in your textbook is my guess. Units squared. Done. That's all we've got to do. Okay? Function of y is in here, and it's with respect to y, and we've shaded in the area that we know we need, and we just integrate from there. Let's try something that's a bit more meaty. Alright, question 6 is deceiving, because now we've gone back to this y as a function of x. So we've got to get rid of that. We've got to get rid of it as y as a function of x. We now need to get x as a function of y. And to get rid of that square root sign, square both sides of the equal sign, and we'll have y squared is equal to x. Bada boom, bada bing. That's a teacher did. We're done. Now we can sketch the thing. X equals y squared is actually just exactly like the first thing that we just did here. Let's sketch it though. That's the y-axis, that's the x-axis. And it's going to look like that. But we only need to go from the y-axis. So here's the y-axis from y equals 1. That's the line y equals 1 to the line y equals 2. Y equals 2. It's this area in here from 1 to 2. And if we do the integral, then we'll have the area is equal to the integral of y squared with respect to y squared dy, from 1 to 2, which gives us, look, it's going to be the same kind of working out as this bad boy over here, y cubed on 3, from 1 to 2, which will give us, we'll have 2 cubed on 3 minus 1 cubed on 3, which is 8 minus 1 on 3, which is 7 on 3, which is equal to 2 1/3 units squared. Done. That's 2 1/3 units squared. Okay, that's the process there. We'll try something a little more meaty again. Alrighty. So for question 12, you guys are really quiet today. So nice. Like, Schiffers, I can't even hear you. It's bliss. Ben, you're about as noisy as you usually are, without the book slapping to get my attention. Strange. And normally I would hear the scribing of Ali G going, shh, 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 shh. I normally hear that, but I don't hear that today. 5. So there are all the bits that we need. Here we've got y as a function of x, and we're going to change that around to be x as a function of y. Okay, that's the first thing that you need, x as a function of y. Because we need a function of y to be in this integral sign. So we just manipulate that until we get x as a function of y. And now we've got x as a function of y. And to find, you know what, I don't even know what that looks like as a curve. You can use Desmos to do that. It shouldn't be too hard to find out if you want to do it. Actually, I do know what it looks like as a curve. It's, oddly enough, going to look very similar to a cubic, but it's going to look different. Anyway, well, it's not going to look different. You're going to look at it differently, I should say. Let's just do, now I know that x is a function of y, so let's skip the middleman. I'll break my own laws about drawing a sketch of what the area should look like. So the area is going to be the integral. Well, it's from y equals minus 1 up to y equals 25. So we're going to go from minus 1 to 25, and it will be this function here with respect to y. And that's pretty straightforward to integrate. So then we put these into here. So now that 3/4 is a constant, so for ease's sake, I'm going to take the constant, multiply it out. So 3/4 is out the front there. And then we'll have 25 plus 2 to the power of 4/3. So 25 plus 2 is 27. That'll be 27 to the power of 4/3 minus, now that's going to be minus 1 plus 2, so that'll be 1 to the power of 4/3, and 1 to any power is going to be just 1. So that's just 1. So what's 27 to the power of 4/3? And 4/3 is an ugly looking kind of a thing. No, it's not really that bad, because a third is just a cube root, and the cube root of 27, what's that? That's right, Duncan. It's 3. So we'll end up having 3 on 4 outside of 3 to the power of 4. And what's 3 to the power of 4? Exactly. Yes. Oh, but who was it that answered that time? I don't know. Who's my favourite? I think maybe it was Sterlo. Sterlo said 3 to the power of 4 was 81 minus 1. And that's just going to be 80, and then 3/4 of 80 is going to be approximately 60. So it'd be 60 units squared. Alright, there's some examples from exercise 3.2 to 3.7. The process is make x a function of y, and figure out what the limits of integration are. In this case it's minus 1 to 25. I skipped out doing the sketch. And maybe you can figure out what I meant by you just needed to look at this curve differently. You can figure that one out. Use Desmos, that might help you. And then we work through the integral as we would at any other stage. Okay, handing over to you.